In this video, we're going to take a look at choosing the right 3D scanner. There are many different 3D scanning technologies out there in many configurations and price points. We are going to take a look specifically at Creaform's handheld 3D scanning systems. Creaform introduced their first 3D scanner called the Handyscan back in 2005, and today has numerous handheld technologies. EMS has been selling and using Creaform 3D scanners since 2006. The models we will look at today include the GoScan, the Handyscan, and the Metrascan. We will also talk about the MaxShot, which works with some of these 3D scanners. These models are offered in a few different configurations that we will discuss. Furthermore, if you would like to watch an in-depth demonstration on any of these models, we have created some very detailed product demonstrations here on our YouTube channel. So let's start by 3D scanning the same part with all three scanners to give you an idea of how they work and the differences between them. Starting with the GoScan. The GoScan is the entry-level commercial model offered by Creaform. The GoScan is what's called a structured light scanner, which projects a light pattern onto the object. This pattern is identified by the sensors to create the 3D shape. It is offered in two configurations, the GoScan 20 and the GoScan 50. These scanners work the same way, and the key difference is in their 3D scanning volume and resolution. They offer pretty much the same accuracy, but the GoScan 20 is intended for smaller parts up to about 20 inches in size. The GoScan 50 can scan 3D objects that are much larger. Both scanners have the ability to capture 3D color for those applications where color and texture would be beneficial. The GoScan works with and without reflective targets. In many cases where you have a part with a lot of detail, targets are not required. However, if you were 3D scanning something that is not very descript, let's say like the side of a car, you would need targets. Now in this example, we're using targets both on the part, and you can see there's this targeted pad here on the table. Reason being, that just helps really lock down the scan as it moves along. A part like this would be difficult to scan without targets. Now, what we're doing is we're flipping the part over now, and we're just using these little fixtures just to keep it off the table. And that keeps the any scan data picked up on the table, keeps it separate from the part, which just makes it easier for editing later. Now, because the scanner had picked up the targets on the table as well as on the part, we want to, because we're flipping the part over now, we need to delete those targets. And we have a few targets on the part that we will reacquire and then begin scanning again and pick the targets back up on the table. Because the relationship between the targets on the part and the relationship with the targets there on the table has changed by flipping the part over, that's why we deleted them. And when we go to start scanning here again, we're going to basically just grab the targets on the part, and that will basically reacquire that orientation of those targets on the part. Then we'll go ahead and pick up the targets on the table itself and then continue scanning on the back side of the part. The advantage of this is it basically allows us to scan it very quickly without having to put lots and lots of targets on the part. As long as those targets are in the field of view of the scanner, it will use them. The only downside to this is you can't move the part in relationship to the table without doing this process of, basically deleting those targets off the table and then reacquiring the targets that are on the part. Okay, here's the complete scan with the GoScan, and you can see it captures the color, and then the color turns off when I rotate and then comes back on. But you can see overall it did a pretty good job. There's going to be some small fine features that it just doesn't have the resolution as some of the other scanners may have, but overall pretty good scan on this automotive trim piece here. Okay, so next let's go ahead and take a look at the Handyscan. Now the Handyscan looks fairly similar to the GoScan. The sensors or cameras are configured slightly different. The key difference is the Handyscan is a laser-based scanner. and it projects out either 6 or 14 laser lines depending on the model. You can see here we're doing 14 laser lines and we're moving across the part. Now, the Handyscan requires targets at all time. And again, those targets can be on the part, they can be around the part, or in this case, a combination of both. And we just move around and scan the part like we did with the Go scan. Going back and forth. All these scanners are line of sight, so that's why having something very portable and easy to move around is very nice. Also, the Handyscan has a single line mode, as you see here, that allows you to get into small holes and crevices and get more resolution, more data down in there by orienting the single line in a different orientation and having the cameras focus in on that. And you can go back and forth from that single line mode back to the 14 or 6 line mode at any time as you're scanning. So again, it has to be able to see at least 3 targets at all times. Now, the advantage of laser scanning over projected light is it does a much better job on dark and reflective surfaces. Basically, the way the lasers work and the return that comes back to the sensors is just better. So we can do higher resolution, we can get into higher accuracy, and we can scan more challenging parts with the Handyscan system. So like the Go scan, we've now flipped the part over to get the other side, and in the software we went in and deleted all the targets on the table, and then we'll start over again. And I've also added a couple of artifacts with targets on them. I just call these vertical helpers. Just help me as you lean over and get the vertical side of the part. Just gives it a few more targets to see. But once again, we acquire the targets on the part that we had left, and then we scan the table to pick up all of those targets, kind of reacquire all of those in relationship to the targets we had left on the part, and then again we just start working our way across the part. Again, all scanners are line of sight, and what's nice about a handheld scanner, especially on this back side where we have a lot of ribs, is I can quickly move back and forth to get all of the different sides. So this part is a very challenging part because of the shape and because of all the fine features, because it's thin-walled with sharp corners is why we chose this part. This is a very, again, challenging part to scan. And you can see we're able to scan this part with both the Go scan and the Handyscan within a matter of a few minutes. We don't need any hard tooling or fixturing. We just simply put it on the table here, work our way around, and scan it. Okay, so here is the finished part for the Handyscan. And as you can see here, part looks really good, very high quality. If you look at the rib areas, very detailed. Really nice looking part. And you would expect that being that the Handyscan offers higher resolution and higher accuracy than the Go scan. So again, very nice looking part. In a matter of minutes, we have 3D scanned this and got very nice detail. Okay, so next we're going to take a look at the Metrascan. Now, the Metrascan is also a laser-based scanner like the Handyscan, and has the option of the 6 or 14 laser lines. It also has the single line mode. But where it's different from the Handyscan is there's no targets required. It'll actually scan in 2 different modes, a mode called static mode and a mode called dynamic mode. And we'll talk about each one. Right now, what we've done is we've set the part up, and in this case, we've set up the part up in a way that we can work all the way around the part, basically 360 degrees, and we're in what's called static mode, which means we can't move the part in this case, okay? So there's the camera system, what we call the C-track, and instead of looking at targets on the part, in this case, it's actually looking at the targets on the head. So essentially what a Metrascan is a smaller size Handyscan with this sphere wrapped around it with all of these targets on it. So that camera system is actually tracking those targets, and then the scanner itself is scanning the scanning the part like the Handyscan was. So the advantage of this is you can pretty much set up and scan. Now, we didn't necessarily have to lift the part up like this. We could have just set the part on the table, scanned one side of it, and then save that. Started a new scan, scan that, and then do a geometry alignment and align the two sets of data. And that's fine, but if it's easy enough to fixture the part in a way where I can get all the way around it, then in a single setup, as you can see here, I'm just going to work all the way around that part. And as long as the C-track system can see that scan head, we can scan the part. So that's one of the real advantages of the Metrascan system. Now, it also has a option called dynamic referencing. And what that does is it uses targets similar to the Handyscan, but they're larger targets. And that's how it identifies those targets from the targets on the actual scan head. So the targets are physically larger, and you could actually place those on a part and scan the part. The advantage of that is then the part can move. And that becomes very handy when you're scanning something very large. So let's say like an automobile or something like that. You can put about 20 of those targets on the part, and actually the whether it's the vehicle or the part could actually move around, or you can actually move that C-track system around. So it lets you scan very large parts fairly seamlessly, and you don't have to worry about noise and vibration. So that's really good for shop floor programming. The other thing the Metrascan system has as an option is a probing system. So think of a CMM, right? So a physical probe. And probing is really good for holes, for small fine features, areas that maybe the scanner has a hard time getting into. Thin-walled parts that have holes like sheet metal, that's where probing is very good. So the Metrascan is somewhat similar to the Handyscan in the sense that it uses the same basic scanning technology, but how it works is fundamentally different with the C-track system, basically tracking the whole scanner, and then the onboard scanner within that sphere is what's picking up the laser stripes to pick up the part shape. So you can use it on small parts like you can the Handyscan, but where it really shines is as the parts get larger, it'll hold better accuracy over distance. You can have the part can move around, and you can still scan and not lose accuracy. Okay, if we take a look at the scan data now from the Metrascan 3D scanner, you're going to see it's going to be very similar in quality as the Handyscan, because again, the Metrascan uses the same Handyscan technology as far as the lasers and the sensors. Obviously, how we track things is different, but given the same amount of time to scan the parts, going over them and getting all the areas, you should see the same quality. Where the Metrascan will improve on the Handyscan is in accuracy when you get on larger parts. But as far as just the look and the quality of it, it should be very similar. Okay, so I mentioned the max shot at the beginning of this video. Now, we're not going to go into a lot of detail, but as you see here, this is a car frame, so it's a fairly large object. The problem with most scanners is, whether it's the GoScan, the Handyscan, or even the Metrascan, you're typically going to start at one end of the part and work your way down towards the other end. And what happens is you start to create what's called a stacking error. So the error that you get with the scanner increases over distance. And one of the ways to try to avoid that is using what's called a photogrammetry system, which is what the max shot is. And you're basically taking a series of photographs with scale bars and other coded targets in the view, and you basically work your way around taking these photos, and then the software will go in and basically create a kind of a master target file for you, so that as you scan over the entire part, you have a very accurate model. So it's really used to increase accuracy over distance. So you can see here, after we've used the max shot, now we'll go back in with our Metrascan, and we have those dynamic reference targets on the part that were used during the photogrammetry, and we can scan the whole part very, very accurately. Now, the max shot only works with the Handyscan and the Metrascan. It does not work with the GoScan. So that's something to keep in mind. Next, let's talk about applications and what are the typical applications for each scanner. Now, that doesn't necessarily mean you can't use one scanner for an application and another. But typically, customers will buy the scanner based on what their needs are. Okay, so looking at applications for the GoScan, things like art and sculpture are a really good fit for this scanner for a few reasons. One, it doesn't require any targets, and if you're doing something like sculpture, it has no trouble auto-aligning the data as you move along. Also, many times these things can be very valuable, and the customer may not want to have to put targets or anything else on it. So anything like art and sculpture is very good. Plus, it captures the color as a texture map. And then things like characters and costumes is another good use. It's also used a lot in virtual reality, animation, and gaming, basically where they want to scan some stuff and have it in that environment. Historical preservation is another good use, similar to sculpture. They want to capture the color. They may not want to put targets or basically disturb it. It may be something very fragile, so that's a good use. Patterns and models is another good use for things, especially like vacuum forming or maybe a master pattern carved out of wood or clay or something like that, which a lot of times leads into industrial design. So anytime you're creating something by hand and then want to get it into a computer. And then medical is also a very good use for the GoScan. A lot of people use it for prosthetics and many other applications where they want to be able to scan a part of a person's body. Also with the structured light, LED lights, it's very safe on the eyes. So those are the typical applications for the GoScan. Now moving on to the Handyscan, applications that work really well for the Handyscan are things that you need higher precision, and they may have more challenging surface types such as the dark and the shiny, and also where you need higher detail. So a lot of things like precision machine parts, plastic injection molded parts, a lot of automotive and aerospace items. Here you see the subframe of a vehicle. Here you see an intake manifold, things like that. Can also be used for inspection. So you basically can scan a part and then bring in the nominal CAD data and actually compare the two to see where they might be different. Another really good use of the Handyscan is getting into tight areas, tight locations, such as inside vehicles or aircraft cockpits. This allows you to get in there and scan everything from the floor to dashboards to seats for things like designing custom fit floor mats. You may want to be able to design car seat covers, dash covers, any kind of aftermarket accessories inside a vehicle. Or as you can see here, we've scanned an entire cockpit of an aircraft for possibly designing things like a flight simulator or trainer. So anytime you want to get into tight areas, the Handyscan is very portable, easy to go in, scans the dark, the shiny, things like that to give you a high quality scan data. Another good fit for the Handyscan are large, heavy industrial items like pumps and impellers and housings, diffusers, things like that. Something where you need the flexibility to go out on the shop floor and be able to quickly scan and create the scan data from that object, many times for then doing reverse engineering and turning that into a full-blown CAD model. But have the ability to go out on the shop floor, and you can see with this item being able to reach in and scan all the internal geometry is very beneficial with the Handyscan, because again of its portability, its small size. It's going to allow you to scan some pretty large objects, but at the same time get into any internal areas and to be able to scan them. So just to summarize what applications work well for the Handyscan, it's going to be where you're going to have more challenging parts or higher accuracy than the GoScan can offer. So things like precision machine parts, injection molded parts that have fine features or require higher accuracy and detail. interiors of vehicles and other tight spaces where you might have challenging surfaces, shiny, dark, or again require a higher accuracy. It can also be used for metrology and inspection, and really works well on small to medium sized parts. Although you can do large stuff like a whole vehicle. Having the max shot as an add-on will help keep that accuracy high over long distances. So it's really the next step up from the Go Scan when you're really looking for a higher level of detail and accuracy. Okay, finally, let's go ahead and take a look at applications for the Metrascan. Now, again, the Metrascan uses these dynamic reference targets that allow you to track the part while you're scanning and at the same time track the scan head. So this is great in a shop floor environment where you might have harsh conditions such as vibration and movement. It's very hard to lock down, especially some large objects like you see here. So that camera system, again, is tracking those targets on the part and tracking the head. And this allows you to move that C-track around to different locations because it does require line of sight, but it'll allow you to very accurately scan a large object. And as you see here, it's got a very large scan volume. And when you get to an area where you can't see it anymore, you can just move it around. So it's very handy and makes it very fast to be able to scan an entire vehicle as you see here. Now, like the Handyscan, the Metrascan does very well on dark and shiny surfaces, but really takes it to another level. It will allow you to not only do dark and shiny, but it'll do contrasting surfaces where you have bright and dark because of a feature it has called Hdr Mode, and that allows the system to switch back and forth to scan those surface types. In addition, it'll do things like pure chrome, highly reflective that the Handyscan wouldn't be able to do without some kind of surface spray treatment. It will scan it with no treatment whatsoever. With the optional Handy probe, you can do shop floor inspection of small to large parts by using this probing system to check features like holes, cylinders, planes, and other features to generate inspection reports. And with the dynamic referencing and the large scan volume, you can do very large parts quickly by being able to move that C-track around to do your inspection. So the applications for the Metrascan include small to large parts, where you need the highest accuracy, especially as the parts get larger over distance, and you can use it also with that max shot for even higher accuracy. Also in conditions on the shop floor where you have vibration or you need the ability to move the part around or that C-track system. And of course, challenging surfaces, dark and shiny, can be scanned with no treatment whatsoever, including chrome. And a lot of metrology and inspection applications are done with the Metrascan. It gives you the ability to 3D scan and probe all in one system. And as I mentioned, it works with the max shot system. So how do you choose the right 3D scanner? Well, really, you need to take a look closely at what your applications are and what it is you're trying to do. Are you trying to do just reverse engineering? Do you also want or need to do inspection? What are the accuracy requirements that you need? What size parts are you typically scanning? What is the surface finish of those parts? Are you ever getting into very tight spaces? What about portability of the system? Do you need to be able to use it inside and outside? Is laser versus projected light important to you? Those are all the things that you need to think about when you're trying to choose the right 3D scanner. And that's something that EMS can help our customers out with. We've been doing 3D scanning for almost 20 years and have a ton of experience in automotive, aerospace, large industrial, medical, and consumer products. So we've scanned and seen just about everything, and we can help our customers choose the right 3D scanner for their needs.